Recording's rolling. It's Wednesday, November 10th. You guys have this page. You've had this page for a while because on the opposite side is your Pulleys Lab. You guys remember doing Pulleys Lab last week? Okay, so if you flip it over, yeah, this mechanical bench lab. This is what we're going to do today to have this out. While you guys are getting that out and go over these other details, then I'll point out how to navigate this. Okay. So I did give you guys textbook puzzles. I think about a week ago. You guys have had these. So here's for AP, here's for honors. So my plan to cover these is the same as it was last time, which is we're just going to cover these in class, and whatever we do in class, as long as you're writing, show all your work and get the answer, and then turn that in, then I'll give you credit for that. You guys, normally, textbook puzzles are a really good opportunity to, of course, practice the subject and solve a bunch of puzzles independently on your own. Okay. Normally, I would assign more of these for like actual homework, except that you guys have so much other stuff. I give you guys AP Classroom and also these take-home quizzes because that works out just a pretty good format, just how this class works out. And of course, you guys have other classes and other things going on in life. So yeah, that's kind of the reason I'm doing it this way. But as long as you just follow along with what we do in class work. But you guys, if you ever have a really deep interest in this class or want to get the most out of it, you could totally take personal initiative and solve a lot more on your own. I mean, that's a good opportunity too, right? You can always give you guys lots of opportunities, so take advantage of those. Friday, well, I do need to get AP class an FRQ, some points to think Friday's a good opportunity. That minor class, since I want to over heads, always good opportunity there. Yeah, so you guys have a energy take-home quiz due Monday. Now, I know a lot of you guys are still waiting for the last quiz to return so that you can do corrections, and I really want to get that back to you guys, but I still have a few students who haven't turned that in, so I'm just waiting. So I got to get everybody to turn in for it. We do have Veterans Day coming up, so there's no school this next Tuesday. Okay. So guys, back to the lab area. Here, guys, everybody else up here. What's going on? I got stands, pulleys, string, weight, breakdown, so everything you need. Meter stakes. It's all back here, so you can do this. If you want to bring all that stuff to your desk, you can, or if you want to do it back here, you can do that too. So I want to have you guys build each of these. Now, guys, looking at each of these, just looking at the geometry, you can tell what is the ideal mechanical advantage. Yeah. Oh, here. Okay. So, guys, what mechanical advantage would you get from this one? Yeah, guys, this is just guys, focus here. It's a few minutes, just a few minutes. The faster I go through this, the faster you can get back there and construct these. Yeah, this is just 1-to-1. He doesn't really multiply your strength at all. All it does is, you can redirect the direction of your pull, right? So maybe that's sort of an advantage, but mathematically it's 1-to-1. Right? But this one, guys, what's the mechanical advantage of this one?
1-to-2.
Yeah, this is I would call this a 2-to-1 on the side of pulling the spring scale. It's kind of like you amplify the strength by a factor 2. Because if this weighs, say, 100 newtons, then what's the tension of the string pulling up here and here? 50 and 50. So right here, you only have to pull 50 newtons to lift it. Okay. Now the catch is, if you want to lift this, say 10 centimeters, how much do you have to pull on your side? 20 centimeters. You pull 20 centimeters here, this will only move 10. And you can confirm this empirically, right? Because you guys have meter six factors. What do you guys think this is? What? 3-to-1. What do you guys think this one is?
5.
Well, I see 1, 2, 3, 4 strings going up. Now, if I unhook this one and lift it over, just suppose I have a double pulley up here, but I loop it over. Okay. Yeah, you could rearrange just a little bit to make 5-1, but as it's shown, it's only like 4-to-1. So a quick way to look at it is you identify the movable pulley. This one's going to move up and down. Okay. And say, well, how many strings are kind of going up, and the weight would split that many ways, right? And that will tell you the mechanical management. And so, guys, the force in, anything that's in is on the side of you pulling the spring scale. So could this be the spring scale reading right here? Spring scale reading? Okay. And then the distance in, could that be how far you physically pull the spring scale? Right, and you have some meter sticks back there. How about the force out? Could that just be whatever weight you attach? So if you attach this weight, what could you call this? How many newtons?
I think you both need each other for this.
5. So this one would be 10. This one would be 5. Right, a little bit different. Okay. Yeah. So that's the weight in newtons. Right. And then how far does that actually move up? corresponding to how far you pull. Right? So now your ideal mechanical advantage is a ratio of the distances, which is just the geometry there. So you might have 1-to-1, 2-to-1, 3-to-1, 4-to-1. Exactly. Okay. The actual mechanical advantage, guys. What do you guys think the actual mechanical advantage is? It's not a ratio of the distances. It's a ratio of the of the forces. Actually, it's right here. Ratio of the force. And this one's hanging up in my room. It's over down that corner. See it? Okay. Okay. Which might be a little bit more, or a little bit less than the ideal. What do you think? Yeah, probably a little bit less. Like if this is a 3-to-1, this might be like 2.7-to-1 or something. I'm just making something up. Right? You might get a little frictional loss, or maybe the fact if these strings aren't straight vertical. Okay. Okay, so there's one more number you can calculate here, and that's called efficiency. So there's a few different perspectives on efficiency. Guys, what Greek letter is this? It's Greek letter eta, ETA. Yeah, okay. Yeah, the poster's no longer my room. Sorry about that. But ETA. Oh, you might have the thumbnail from first day as well. And so there's a few different perspectives on this. But the one you guys can use for this lab today is actually this bottom version. So it's the ratio of actual compared to ideal mechanical advantage. So here, let's do those numbers I just said. You've got a 2.7-to-1 mechanical advantage actual compared to a 3-to-1 ideal. That would be 90%. Wouldn't that be 90% efficiency? Right. And then 10% of the work you do would go to maybe things like frictional loss or that sort of thing. Right. All right, you guys think you can figure this out? Here, actually, I'll leave this one up. Okay. And then All right. So just turn in the lab at the end of class.
All right, guys.